In section 6.3, we will start talking about logarithmic functions. First off, let's talk about the definition of a logarithmic function. The logarithmic function with base a, where a is greater than 0 and a not equal to 1, is denoted by y equals to log base a of x. And this is read as y is a logarithm with base a of x. And is defined by y equals log base a of x if and only if x equals to a to the y power. Okay, so let's break that down. Let's say we have log base a of x equals to y. This is the logarithmic form. Any equation in logarithmic form can be rewritten as an exponential equation in exponential form. So how do we do that? Well, the base of the exponent, or sorry, the base of the log becomes the base of the exponent. And then the x and y, they flip. So the y becomes the exponent and the x becomes the answer. And the reason for this is because logs and exponents are inverses of each other. So remember that if we have xy to find its inverse, we reverse the order and make it at y comma x. So similarly, if we have log base a of x equals to y, when we rewrite this as an exponential equation, the base stays the same. The base of the log becomes the base of the exponent, but then the x and y, they reverse. So the y becomes the exponent and the x becomes the answer. There are two exceptions. If we just have log of x, then it's assumed to have a base 10. If you see the terminology ln, that refers to natural log. So when you have ln of x equals to y, this is a logarithmic function with base e. So ln x equals to y, this is actually just log base e of x equals to y. So ln, natural log of x, is just a log with base e, which is a natural number, or Euler's number. Okay. Let's write the equation in exponential form. Each equation, we're going to write in exponential form. We have log base a of t equals to c. So this is the logarithmic form. Now, when we write in exponential form, the base of the log becomes the base of the exponent. And the t and c, these are going to switch sides. They're going to reverse. So the c becomes the exponent, and the t becomes the answer. Next one, the base of the log, which is the 5, that's going to become the base of the exponent. The 3 becomes the exponent, so we get 5 cubed, and that equals to 125. So it's the base, which is 5 to the third power, equals to 125. The 3 and the 125, they reverse. Log of x equals to 3. Well, in this case, we don't have a base. If there's no base written, that's going to be base 10. So this is going to be 10 to the third power equals to x. Now finally, we have natural log of 5 equals to x. So first thing I'm going to do is I'm going to rewrite this as log base e of 5 equals to x. So the natural log is log base e of 5 equals to x. And then we have e to the x equals to 5. We got the base raised to the x power, and that's going to equal to 5. Next, we're going to take equations that are in exponential form and rewrite them in logarithmic form. So the same principle applies, except we're going backwards. The base of the exponent is going to become the base of the log. So this is going to be log base 5. And then the u and the v, they switch sides. So the v goes to the log, and the u becomes the answer. Next one, we have a base of 10. So we're going to have log base 10. the 1003, they reverse sides, so the 1000 comes to the left and the 3 goes to the right. Now, log with the base 10, we don't write the 10. It would be incorrect. So we're going to write this as log of 1000 equals to 3. Okay, letter C, we have e to the t equals to v. So once again, the base of the exponent becomes the base of the log. So we have log base e, and the t and the v, they reverse. So the v comes to the log, and the t goes to the right side, becomes the answer. So if you leave it like this is not fully correct, because when we have log with the base e, that is the natural log of v equals to t, and this would be the correct way of writing the answer. Okay, lastly, we have e squared equals to y, so we have log base e of y equals to 2. The base of the log, so the base of the exponent is the base of the log, the 2 and the y, they switch sides. Now log base e, that's equal to natural log, so we have the natural log of y equals to 2. So for both of these, remember that the base stays the same, and then these two, they reverse sides. Okay, so next we are going to solve each equation. Let's start with the first one. To solve the equation, okay, let's back up. Let's say I wanted to solve the equation x plus 1 equals to 2. So what would I do? Because the x is being added by 1, I do the inverse of addition, which is subtraction, and I subtract 1 from both sides, and we get x equals to 1. So why do we subtract? Because to undo addition, we have to take the inverse of addition, which is subtraction. Similarly, the inverse of a logarithmic function is an exponential function. And we always use inverses to solve equations. So if I'm solving x plus 1 equals to 2, the inverse of adding is subtracting. That's why we subtract. That's how we get the x by itself. In order to solve for x in this case, we do the inverse of a logarithm, which is an exponential function. So I'm going to say the base of the log is 3, that stays the same. My exponent is a 4, and that equals to x. 3 to the 4th power is 3 times 3 times 3 times 3 equals to x. And then this equals to 81, so we get x equals to 81. Okay, the next one, we have 2, that's going to be our base. The negative 3 and u, they reverse, so we got 2 to the negative third equals to u. We learned in the last section that 2 to the negative third is equivalent to 1 over 2 to the third, because we can't have our answer with a negative exponent, so we move that to the denominator to make it positive. And 2 cubed is 2 times 2 times 2, so we're going to get u equals to 1 over 8. Next one, it says we have log base x of 32 equals to 5. So we're going to take our base x, 32 and 5, they reverse. So the base stays the same. The 5 becomes the exponent, and then 32 becomes the answer. Now, we also learned in the previous section that if you want to solve for x, the way you undo an exponent is you raise the exponent to its reciprocal. So we raise the left side to the 1/5 power, which means we raise the right side also to the 1/5 power. And the reason we do that is now when you have a same base that has two powers, they multiply together. And 5 times 1/5, that gives you 1. So we get the x by itself. And in a calculator, put 32 to the 1/5 power, which will give you 2 as the answer. So our answer is x equals to 2. Okay, same thing over here. We have our base is x, so we have x raised to the 6th power equals to 729. And we take our base x, it's raised to the 6th power. So to undo that, we have to raise it again to the 1/6 power. And we raise the right side to the 1/6 power. In order to undo a power, we raise it to its reciprocal. And what do we get? On the left side, we get x because 6 times 1/6 is 1, and 729 to the 1/6 power, if you put that in a calculator, you're going to get x equals to positive 3. Now the last few, these are just, you put them on a calculator. So here you just have to know how to use your calculator. So all your calculators will have a log button. And if you take the log of 1000 and put that in a calculator, you're going to get 3 as the answer. And again, this is all calculator work. If you do log of 1 over 1000, and be sure to put this in parentheses. If you put log of 1 divided by 1000, if you do this without the parentheses, you're going to get an incorrect answer because the calculator is going to think do log 1 first and then divide that by 1000, which is not what we want. So make sure you put log parentheses 1 divided by 1000 or 10,000 rather, and that will give you -4 as the answer. All right, so practice that. Make sure you guys know how to use the log button in your calculator. The next one we have ln, which is a natural log of 0.032. So once again, all we're doing is putting this in a calculator, and we're going to get -3.44. Then lastly, we got the natural log ln of 329. So let's take the natural log of 329, and we end up with 5.80. It's 5.796, but if we round that to 2 decimal places, this will give you 5.80. And that's it for this section.